Hello. Today's topic is electromagnetic spectrum. Today's topic is electromagnetic spectrum. So basically, the electromagnetic spectrum is arranged in a specific order based on the wavelength of frequencies. It is arranged in a specific order based on the wavelength of frequencies. I have also written the definition of what it is. Um, the main groupings of the continuous electromagnetic spectrum. Electromagnetic, I've made the short form of electromagnetic spectrum. I have wrote it as EM. All right. So the main groupings of the continuous electromagnetic spectrum are the ones that I've mentioned here: radio waves, microwaves, infrared, and visible light. In visible light, you have the Roy G. Biv structure, in which we studied about red, orange, yellow, green, blue, indigo, and violet light. Then you have ultraviolet, then you have X rays, and then you have gamma rays. The order is shown in the diagram. This is the diagram which I got from the Google basically. Yeah. So the order is shown in the diagram below from the longest to the shortest wavelength. From the longest to the shortest wavelength. If you can see here, the radio waves, they have the longest wavelength, they have the lowest frequency, and they have the most lower energy. And then when we talk about gamma rays, they have the shortest wavelength, they have the highest frequency, and they have higher energy as well. So it starts from the radio waves, and radio waves is the longest, and gamma rays is the shortest. So you can see the diagram here. You can see from one crust to one crust, the distance of the wavelength. It is decreasing till it reaches gamma rays. You can see the distance is being decreased. All right. Visible light is basically just one part of a much bigger spectrum. So the points which you need to remember here is that the higher the frequency, the higher the energy of the radiation. The higher the frequency, the higher the energy of the radiation. Radiation with higher energy is basically called as highly ionized, or you can say it is highly ionizing. Basically, what are the harmful things which would occur is that it is harmful to your body cells, it is harmful to your body tissues, which also causes cancer. Okay, so for example, things which are used to treat cancer are gamma rays, x-rays, and UV. Radiation with lower energy, which means it has less energy. For radiation, it's basically used for communication, and it is also less harmful to the humans. Why is it less harmful to the humans? Because obviously it has low energy. If it had high energy, then it would be harmful to the human body, which I said earlier, as it is harmful to your body cells and your body tissues. Now, when we talk about the properties of electromagnetic waves, electromagnetic waves are basically defined as they are transverse waves that transfer energy from the source of the wave to an absorber. From the source of the wave to an absorber. All electromagnetic waves share the following properties. The properties I have mentioned here, that they are all transverse. They all can travel through vacuum. They all can travel through vacuum. They all travel at the same speed in a vacuum. Means the speed in which they travel at the vacuum, that speed is same, it does not change. The seven type of electromagnetic waves together form a continuous spectrum. Now, the speed of electromagnetic waves in vacuum is 3.0 times 10 to the power of 8 meters per second. You can also say it as 3 times 10 to the power of 8 meters per second. This speed is approximately same as the speed of electromagnetic waves in the air. Now that we've reached this far, we're going to talk about the uses of electromagnetic waves. These uses means applications, like where do you use it in your daily life. When we talk about radio waves, you can say that yes, it is used for communication in radio and TV. Microwave, you can see microwaves in the household stuff. It is used for heating food. And then communication such as Wi-Fi, mobile phones, satellites. Infrared sensors, you basically call it as infrared sensors, where you can see infrared sensors in the malls, the doors, the entrance of the malls. You can see the two doors, and they have a small sensor which detects the person coming, and then it opens the door. So the applications of electromagnetic waves, infrared waves, it is used in remote controls. If you have a television remote, you can see a small light in front of the remote, okay, and it has a red light. So that basically is the infrared light. Fiber optic communication, thermal imaging, which is used in medicine and the industry, night vision, heating or cooking things, motion sensors for security alarms, electrical heaters, and infrared cameras. Infrared cameras means by CCTV cameras. Visible light is basically seeing and taking photographs and videos, and fiber optic communication. Ultraviolet light is used for security marking for fluorescent bulbs, energy efficient lamps, or getting a suntan. If you go outside, the sun is really bright, and then you come back home and then you say that I got tan. So that's a bit basically you got the ultraviolet rays. Then you talk about X-rays. X-rays is very common. You use for if you have a fractured bone, if you have anything, you go to the doctor and then you tell the doctor, please take an X-ray of my hand. So that X-ray machine, the X-ray image is used in medicine. It is also used in airport security and industry. Airport security, when you put your luggage for security check, that's the place where X-rays are being used. Gamma rays is basically used for sterilizing medical equipments, and it is used for treating cancer. The electromagnetic spectrum and the summary and uses and the dangers of it. If you see here, radio waves, it's used for long range communication because they can be reflected from the Earth's atmosphere. Similarly, when you talk about microwaves, satellite communications, because microwave can penetrate the Earth's atmosphere. And then we talk about infrared. It is used in optical fiber communication because they can undergo total internal reflection. If you go back to my lecture, in which we have discussed about total internal reflection, I gave an example of optical fiber. So optical fiber, they undergo total internal reflection. And then we spoke about visible light. Visible light is like normal light, your camera, phone, and stuff. So used for taking photos and videos. Cameras are set to detect visible light. Ultraviolet for detecting security ink because it fluoresces with ultraviolet lighting. X-rays used to photograph bones because X-rays can penetrate soft tissues, but it cannot penetrate bone. All right. Then we talk about gamma rays. Gamma rays is used to sterilize medical tools because gamma kills bacteria. Now, the danger in gamma rays is that gamma and X-rays can have high intensity, and high intensity ultraviolet can harm the cells and it can cause cancer because they are highly ionizing due to having a lot of energy. Gamma rays, X-rays, and UV light, gamma, X-rays, and ultraviolet, they have lots of energy, which means they're highly ionized and they can cause cancer. Talking about the high intensity of microwaves, it can cause internal heating of internal organs because the water molecules, they absorb microwaves strongly. I hope you understand everything from today's video. See you in the next video.